interpretation? He's dead right. Okay. There's millions of diabetics, whether it's diabetes 1 or 2, and insulin for many of them is a necessity. Thus, they are not price sensitive. Right? So their demand is going to be very inelastic. In contrast, cruise is a luxury. If prices increase by 20%, some people will just forego that demand. Yes?
So we've done a bunch of examples where prices rise, but the same thing applies when prices fall, right? So nobody, when prices rise, nobody needs more.
Yes. It's symmetric. No question about it. Yes?
Does insulin have any sort of elasticity, or do they any better?
Well, certainly if you... Yes, it does have some elasticity. For example, suppose you have no insurance, and suppose you have no income. Then you're going to be responsive to price increases. But that's just a small segment of the buying population, right? But there is some sensitivity there. But certainly not as much sensitivity as there is for a luxury item. It's not a basic necessity. So, lesson. Price elasticities are higher for luxuries relative to necessities. And that's just common sense, right? There's no... One doesn't have to be an expert in economics to figure out that this makes good sense. All right. Okay, another example. Gasoline in the short run versus gasoline in the long run. Once again, as in all these examples, prices are increased by 20%. And now we're not looking at two different goods. We're looking at the same good but at different points in time, right? Okay, you can think about that as two different goods because you're thinking about what's your response. What's the demand response to gasoline prices that have increased by 20% over the next week versus what's your response to gasoline prices that have increased by 20% over the next 5 years? Yes. Oh, but you already got the last one. Come on. Let's have a new... Yes.
People will be able to change their lifestyles in the short run, so they're going to be fine, but in the long run, they're going to change their actions to...
Exactly. Does anybody want to amplify on that or disagree with it? Pardon? You're dead right. In fact, there's been empirical studies. You haven't done those empirical studies, right? You're just using common sense. But there's been formal econometric or economic studies using statistical analysis to show just that, right? But the fundamental point is the point that you made, namely that in the long run, there's all sorts of adjustments that people can make that they can't make in the short run. They can buy smaller cars. They can buy hybrid cars. They can move their residence closer to their work and walk to work rather than driving to adjust to the gasoline prices. If you go back to 2008, what was happening up to 2008 in the United States, and certainly here in California, that people were moving larger and larger distances away from their place of work. People living in Tracy. Everybody knows where Tracy is, right? If you've been there, you want to forget. I'm sorry. There's no one here from Tracy, right? But anyway, but a lot of people moved to Tracy, and it's a long commute from Tracy to a workplace in San Francisco. And that made sense when the price of gasoline was $2 per gallon. In 2008, when prices went to $4 and above, it no longer made sense. So as a result, you've seen a natural evolution of people, instead of living long distance away from their place of work, as prices of gasoline go up, they're moving closer and closer to their places of work, which makes good economic sense. So the price elasticity is generally higher in the long run relative to the short run. Okay, to summarize everything that we discussed up to this point in time, the price elasticity of demand depends on the extent of close substitutes and how readily available those close substitutes are. It also depends on whether the good is a necessity or a luxury. It depends on how broadly or narrowly defined the good is. And that comes back to our blue jeans versus clothing, right? And in general, it depends upon the time horizon with regard to the period over which buyers can adjust to a price change. Okay? All right. Now, what are the different types of demand curves? What I want to do now is provide you with 5 different classical demand curves and what their elasticity is. Once we've done that, then I want to go from there to what are the implications for total revenue. Because coming back to the website, if I'm thinking about increasing the price of my website services, before I make that decision, I should stop and figure out what the price elasticity of demand is. And it doesn't pay to experiment, because if it turns out that the demand facing you is very, very elastic, and you increase the price to $2.50, and you have no demand whatsoever, you'll starve to death. Right? Assuming that's your only source of income, right? Okay. So, what are the different types of demand curves? All of them are very closely related to the slope of the demand curve. And the rule of thumb is the flatter the curve, the bigger the elasticity. Well, why is that? If the curve is very flat and you have a small change in price, you got a big change in quantity, right? The steeper the curve, the smaller the elasticity. Now, there are 5 different classifications of demand curves. And what we're going to do is take all these demand curves and put them into 5 buckets. And we'll go from one extreme to another, namely a demand curve that's perfectly inelastic to a demand curve that's perfectly elastic. Okay. Perfectly inelastic demand. As you see here, it's a vertical line. And what that says is the demand is going to be the same regardless of what prices are. Right? So there's no price sensitivity here at all. Okay? Consumers don't care what the price is, or the buyers don't care. And as a result, the percentage coming up to the top here with regard to the formula, percentage change in quantity relative to the percentage change in price, that is nothing more than the 10% move with regard to prices, the 0% move with regard to quantity, and we get an elasticity of 0. Okay? All right, let's go to the next one. An inelastic demand. Now there's some sensitivity, but it's very low sensitivity. It could be the demand for a particular brand of beer, and you're very loyal to that particular brand. And regardless, if there is a change in prices, it's not going to move or change your behavior very much, to some degree, but not very much. You may not switch to other beers, but you just drink less of that beer. Okay, here the price fall is 10%. What happens with regard to the quantity change? It's less than 10%. So I take the ratio of those two percentages, I end up with an elasticity less than 1. Right? All right, the next bucket is a unit elastic demand. And this is a curve that has an intermediate slope, but the consumer price sensitivity is also intermediate. And if we look at a price fall of 10% and we look at the quantity change has to be the same, right? The quantity change is going to be 10% as well. So I take the ratio, coming back up to the simple formula, I take the ratio of the percentage change in quantity relative to the percentage change in price, and I get my unitary elasticity of 1. Okay? Elastic demand. Now the buyers are sensitive. Consumers are price sensitive. It's relatively high. The price change, however, is going to be relatively mild. But going through the percentage change here, looking at a 10% fall, the quantity change now is going to be greater than 10%. Okay? So as a result, an elastic demand curve is one whose elasticity is greater than 1. Right? Okay? And then finally, the last bucket is a perfectly elastic demand, which is the extreme of the perfectly inelastic demand. Right? And here, a mild change in prices will reduce the quantity demanded to 0. Right? And in this particular example, if we go through, the percentage change in price is 0. And quite obviously, it turns out if there's a 0% change in prices and there's some positive change in quantity, any positive change, we're going to have an elasticity of infinity. Right? All right, so those are the 5 basic buckets. Now let's look at a widely employed demand curve, namely a linear demand curve, and ask ourselves the question, what happens to elasticities along a linear demand curve? Is it constant? The slope on the demand curve is constant, right? And we said the elasticity depends in part on the slope of the curve. It turns out that it is affected by where we sit with regard to price and quantity. Let's draw the linear demand curve and look at the elasticity as we move along that linear demand curve. First, for a movement in prices from 30 to 20, computing this arc elasticity, taking the midpoint, right? That's going to be an elasticity of 5. Cap E here is the symbol for elasticity. And then if I look at the mid part of the curve, again, even though the slope is constant, the elasticity for the midpoint, or around the mid-range of the curve, is unitary elasticity. Okay? And then finally, in the lower part of the curve, it turns out that that portion of the curve is inelastic. Okay? So as we'll see in a moment, if the elasticity is very closely related to the revenues that are being generated, coming back to this person that is selling web services, it depends on where he is on that curve with regard to a price change that he wants to make or she wants to make and the revenues that will be generated. Clearly, we'll see in a moment that if he is in this range, then it may be in his best interest to increase the price. However, if he is here, it may not be in his best interest to increase the price. Okay, now let's turn to using the elasticities to inform us about what's going to happen with regard to total revenues. And now I want to return to our original example, namely this person that's selling their web services and they're thinking about raising their price from $200 to $250. And we ask ourselves the question, will this person's revenues rise or fall? Revenue is nothing more than price times quantity, right? So initially, if the price P is equal to 200, this person is thinking about changing P from 200 to 250. He knows what was the quantity that he was selling? Pardon? 12. He was selling 12. So we know what the total revenue is before he makes the change, right? And now what we don't know is what the quantity is going to be after he makes the price change. Okay. In general, in principle, the price increase is going to have 2 opposing effects on revenue. If the price is being increased, the price increase is going to lead everything else constant to more revenues. But since there's a downward sloping demand equation or curve, there's going to be a fall in quantity. The fall in quantity is going to have the opposite effect on revenues, right? So let's clearly, what I've already said, namely a higher price means more revenue on each unit that's being sold, but there are going to be fewer units given the law of demand. Okay? Which of these 2 effects is bigger, that is to say the price per unit, or the fewer number of units turns directly on the price elasticity of demand? In fact, if you tell me what the price elasticity of demand is, I can tell you immediately what the effect is going to be on total revenues from a price change from 200 to 250. And we'll go through this. Okay, so returning to the price elasticity of demand, recognizing how revenues are computed. If the demand is elastic, then, as we've just previously defined, the price elasticity of demand must be greater than 1, right? So the percentage change in quantity is larger than the percentage change in price, right? And as a result, the fall in revenue from a lower quantity being sold is greater than the increase in revenue from the higher price that's being charged. So total revenues will fall. Now let's look at the actual graphic analysis. Sure, got it? Okay. Elasticity of demand of 1.8. Let me go through and show you graphically what is going on with regard to the relationship between the price elasticity and what happens with regard to total revenues. What I've got here initially is the basic information. This is this person's prior performance. They charged a price of $200. They were selling 12 per month, and each month they were getting a total revenue of $2,400, right? And I've shown on this graph, this is the vertical axis price, this is the quantity here. What's this rectangle here, this blue rectangle? What is it? Pardon? Revenue. Total revenue. That's all it is. I've shown you graphically what the total revenue is, and this blue rectangle is $2,400, all right? Okay, now we want to look at a change. Namely, we're going to increase the price to 250, and we know when we do this, the quantity, given this elasticity, the quantity is going to fall to 8 units. And now the total revenue that's going to be generated is 2,000. Now there's a loss of revenue of $400, right? What's the source of that loss? Part of that loss is a lost revenue due to lower quantity, but that is offset by the price per unit increase for the 8 units that I'm selling, which is represented by this rectangle here. So the increased revenue due to a higher price is the yellow rectangle. The lost revenue due to a lower quantity is the blue rectangle, okay? And quite clearly, since the loss of revenue due to a lower quantity, this area is larger than this area, this person better have very high opportunity costs, right, of their time making websites. So the result or the conclusion is when demand is elastic, a price increase causes revenue to fall. Now let's look at an opposite example, and this is just going through the same steps. Now, but focusing instead on a demand curve that's inelastic, not elastic. Now, the price elasticity of demand is less than 1, and as a result, the percentage change in quantity is less than the percentage change in price. The fall in revenue from the lower quantity is going to be smaller than the increase in revenue from the higher price. So as a result, revenues must rise. And because of the inelasticity, now the quantity demanded doesn't fall to 8. Instead, it falls to 10. Let's look at this graphically. Okay, I'm going to do this analysis for an elasticity of 0.82, 0.82. Once again, specifying the initial conditions. The total revenues here, graphically, is the $2,400 represented by this rectangle. And now I'm going to look at what happens as the price increases to 250, and the new quantity demanded, reflected here on the horizontal axis, is 10. Now, note that my total revenues have increased from 2,400 to 2,500, and this turns out to be the outcome because the lost revenue due to lower Q is much less than the increase in revenue due to the higher price. So, should this person facing this inelastic demand increase their price? Absolutely? Really? Are you sure? Absolutely is a strong word. You know, do you notice whenever they interview sports figures and they ask them about their play or somebody else's play, the word is always absolutely. There's no uncertainty. Okay. If this person only cares about total revenue, absolutely. If this person cares about profits, not necessarily. Because suppose their costs actually went up more than the increase in revenues. We'll return to that later. All right? So it's when you say absolutely, give the conditions. Absolutely if the person only cares about revenues.
The conditions of making a website most of the time.
Okay. Yes?
If you make less than anything, would your costs not increase? How would your costs increase if you made 2 less websites?
How would your cost increase?
You said maybe it's not most profitable because maybe perhaps its costs are up.
It depends on what other opportunities this person has. Your intuition is right. If I'm decreasing the quantity, I would expect myself to move down the cost function, not up the cost function. I just want to be careful about absolutely, that's all. All right. Okay, so what's the conclusion? The conclusion is, if demand is inelastic, a price increase causes revenues to rise. All right. Let's move on to a concrete example. It's something that none of us are familiar with, hopefully. Drug addiction, interdiction. There are governmental policies that focus on intervening and attempting to control the supply of illegal drugs. And this includes burning cocoa in Bolivia. It includes what's going on in Mexico with regard to trying to control the production of illegal drugs. And all of these policies are designed to try to change the supply function, right? And there are unintended side effects of such governmental policies. And we want to examine 2 different policies. One policy is designed to reduce the illegal drug use. And one policy is going to focus on the demand side, and one policy is going to focus on the supply side. And we want to see what are the implications with regard to drug-related crime. And to help with this thought experiment, let's suppose that people that are using illegal drugs because they're largely dysfunctional and they don't have a source of employment, and moreover, all their friends and family are so disgusted with them, they will no longer support their illegal drug use. So, under those circumstances, that's hypothetical, I understand, the only source of resources that they can capture to pay for those illegal drugs is by stealing, right? Okay. Now, under those circumstances, we'll assume that the total value of the drug-related crime is equal to the total expenditures on drugs. Okay? So, the people that are demanding these drugs in this hypothetical thought experiment, they can only pay for those drugs by stealing from others. Okay. And moreover, all the empirical studies out there have shown that the demand for illegal drugs is very inelastic. It's not price sensitive. Okay? And that's the direct result of addiction. Okay, given those circumstances, the first policy, as I discussed, this is a policy that's going to involve trying to shift the supply schedule. And what I've represented here is the initial conditions. This is the quantity of illegal drugs moving through this illegal market at this particular price. Right? And now, an attempt on the part of government to reduce the supply of such drugs. And that event will end up shifting the supply schedule to the left. And when it shifts that supply schedule to the left, we end up, because demand is inelastic, prices rise proportionally more than quantity falls. Right? And all I'm doing here is illustrating that point. Price for the supply shift is going to move in the new equilibrium from P1 to P2,